Yes, good morning, everyone. So yeah, we're going to talk mostly on weather outside of Central Region here, but a lot of the stuff that we're going to cover are things that are good to keep in your mind in your toolbox for applying to events when they do come up here in Central Region. So we're going to look at a variety of tools for these upcoming events. Some of these you may have heard being covered in past talks, but this is good to kind of review a lot of this material. In fact, one of those mClimate we had talked about for a while. It's been a long time since we brought that up, so that will be covered, and we'll show some violin plots and that. So this should be a pretty good talk for y'all. So we're going to start first for the Western U.S. The heat event. So hopefully a lot of you are using some of this cluster analysis data. If you haven't, it's a very good resource to be able to look at all the ensemble data in a very simplified view. It's a way it just groups similar ensemble members into 4 clusters, and then these images also usually show a mean of all together. But these clusters really help to break down what are the not necessarily most likely, because they give you percentages for each one, but what are the potential outcomes of for the synoptic patterns and QPF and other things. What's also nice about this cluster data is that for some of the elements of the MBM shown there, like the QPF, the POP, the probabilistic max T min T, this data helps to kind of give you peel back some of that black box of the MBM and tell you why the MBM is doing what it's doing. So in this example here, I've got from the cluster analysis, looking at from the ensemble data from yesterday, looking at July 10th, you see this very strong ridge over California, Arizona, Nevada, poking up through the Pacific Northwest, very above normal heights there, delineated by the warmer orange, yellow, orange, reddish colors there on the image. When you go into Sunday, there's a little bit of a flattening of that ridge, but it's still very strong over California, Arizona, and Nevada. And that ridge just sits. There's very little movement to it. It continues to flatten over the Pacific Northwest, but again, the 500 heights remain quite a bit above normal in this situation. Finally, by Tuesday, some of this starts to break down with you get a couple of clusters 3 and 4 delineating some potential for some trough in the Pacific Northwest, albeit it's a very small percentage, a total of 22%. The majority of the ensemble members still project at least a zonal and above normal height kind of flow there across the Pacific Northwest. But focusing back down to the subtropical ridge there, it's still pretty going strong there across Southern California. So one of my personal favorites of some of these quick tools to look at is the ECNWF Extreme Forecast Index and Shift of Tails. The Extreme Forecast Index, or EFI, it's really a quick measure of the amount of extremity in an ensemble relative to that ensemble's model climate. So the model run, you look back at the past like 20 years centered on a 5-week window, and see what's how extreme the situation is. And I can better show you this based on this graph, and this comes from some of the ECNWF EFI training, where the model climate is that black curve, the ensemble members are the red curve, and then the EFI is essentially that area in between. EFI is capped between -1 and +1. And so one of the problems here in the CFI, and you can see it in big black letters up at the very top, it takes no direct account for any ensemble members beyond the climate extreme of the mClimate. You can see the mClimate peaks out there in this image at 23 Celsius, but there are members that go beyond that. So that's where the shift of tails comes in. And the shift of tails tells you how extreme an extreme event might be. And you're looking at the top 10% to figure that out. And I should say that there is a new vignette on this topic. If you haven't seen it yet, take a look at it. It's short. That's like all these vignettes are supposed to be. So again, just giving a shout out to that. So let's take a look at some of that EFI data for this Western US heat event. I've just looked at the Western US here. There's various different domains you can select, similar to like the cluster data. You can just select like the Western US or Central US. Here I've got one of the points labeled Hanford, so you can look at, and then if you go to the ECMWF Open Charts website, you can pull up these really cool graphical displays of the CDF of the ensemble members, and what's cool too is it will show you past cycles of the EFI all on the same chart. So like in this graphic, you're seeing some previous cycles in the blue, and then the latest cycle is in the red. And you can see that with each, it looks like pretty much for each successive run, you're getting farther and farther to the right. EFI therefore is increasing with time, and now the EFI is basically peaked at 1. But you also see, the M climate peaks at about 30, maybe about 37 Celsius, and there's a lot of ensemble members here that are to the right of that peak, and so that's why you have a shift of tails there. That black circles surrounding Hanford of 1 value. That's again representing that top 10%. Note that this is there is some slight difference between these two images. The one on the left is a max temperature. The one on the right is a mean 2-meter temperature. One other item I did want to throw on this, while I'm looking just generally at Hanford here with respect to Central Region Grand Junctions area, you can see there's also a delineation of some high EFI values and an SOT of 1. And I did have to look at that, and it looks like there's several members forecast in temperatures above 100 degrees from this from this cycle. So go to July 10th. Here's the same kind of deal. That it should note that the EFI is expanding in area, as is the SOT. Not much, it's just getting a little bit warmer. Now we start to get towards the peak of this heat event with July 11th. The SOT is getting close to 2, and you can really see that in the graph that you're getting a lot of ensemble members above 39 Celsius. They're on for the mean 2-meter temperature. It's getting farther and farther away from that M climate curve. And then by July 12th, so that the bummer part on the ECMWF EFI Open Charts website is that they only do a few days for those displays. So then I went to Weather Bell here to just grab an image of what July 12th looks like, and you can see there's lots of ensemble members for Hanford, suggesting high temperatures above 117, even quite a few above 120 degrees. Again, the SOT is sitting right there near 2. So one other thing I wanted to cover here, because we're, that past slide for the European, showing all these ensemble members, and we talked clusters. Now is to talk about this now all in a probabilistic framework, and this will be kind of a review from our last guest speaker series on this sort of topic about temperature forecasts, and talk about the MBM probabilistic data. So the MBM probabilistic data uses 171 model members in the first 24, and then gradually drops as you get out to day 10. It has a bias correction for the past 72 days for each model member. There is no raw model guidance included for the probabilistic distribution. This kind of framework does create some issues in transition seasons, and we saw that back in May when we were having some well above normal temperatures, but the probabilistic data was having problems with it because you had a analysis archive that was cold, and then so that's spring to early summer, and then you have the reverse. The reverse is going to be true when we get to fall and early winter, where the analysis archive is warm. Now that we've been kind of situated in the middle of now in the middle of summer, that analysis archive is now a little more representative of what we are seeing today. So the probabilistic data should be a lot more usable, if you will. The deterministic temperature data, not nearly as many members utilized here. 16 members, deterministic and ensemble means, that are dynamically weighted. So there's kind of this idea of some expert weighting for the first 36 hours, and then 10 members for beyond 84. And here again, it's a DKM model bias correction employed. So you put more emphasis on the first, on the first couple weeks, and then drop it significantly by the time you get to 60 days. This methodology is nice when you have a lot of, if you have changing weather patterns, because again, your bias corrections, the probabilistic 72 days, the bias correction on the deterministics only, maybe a couple weeks at most, where you're getting a lot more emphasis. So if you're looking for the change in weather patterns, the MBM deterministic does a pretty good job with that. So again, these two are to be considered as apples and oranges. So now we're on the topic of MBM, I'm going to pass this over to Jonathan DeGraw, where we're going to look at this heat event from an MBM perspective.
Hello, everyone. It's a pleasure to be with you all today. Just to confirm, can you guys hear me?
Yep.
Sweet. So Andy just discussed the difference between the NBM deterministic and probabilistic calculations. And as he just said, and as has been discussed in previous presentations, they're different, they're apples and oranges. And here we're going to be looking at both of them just to see what each of them says. So on the right, we have the deterministic max T forecast. This was for yesterday morning. I took this yesterday morning. And also the probability of exceedance of 110 degrees, which I also pulled from this morning. I would like to note the newer runs are trending a little bit warmer. And we will look at some of those forecasts for today, some point forecasts that were taken from this morning. But I did just want to make that note here. So you can see here, this is Thursday, tomorrow. You can see that in the Indian Wells Valley, where China Lake is, it's starting to get a little bit warm there. But in the San Joaquin Valley, at least on the probability of exceedance of 110 degrees, there's not much chance of that tomorrow. But as we go on to Friday, we can see that those chances do increase. That chance of probability of exceedance of 110 does increase in the San Joaquin Valley. Pretty much stays the same in the Indian Wells Valley near China Lake. We go to Saturday, the chances increase again. And then we go to Sunday, and Sunday's Sunday's forecast is projecting the highest temperatures. So the highest temperatures of this heat event appear to occur on Saturday, or sorry, on Sunday, both at Hanford in the San Joaquin Valley and in China Lake. And the reason why those are labeled there is because we'll be looking at those point forecasts here in a bit. And then we go on to Monday and Tuesday, and you can see those chances diminish over both the San Joaquin Valley and the Indian Wells Valley. So you can see that both the probabilistic and the deterministic forecasts pretty much that they are in agreement with the timing of the event. So looking at some point forecasts here, like we mentioned previously, the NBM is showing Sunday to be the warmest day of the heat event. This is for China Lake in the Indian Wells Valley, and you can see the 25th percentile is 116 degrees, median 118, and the 75th 120 degrees. And you can see the deterministic is between, or it's right at the median there at 118 degrees. And by the way, just to note, this is from this morning, so this is the newest run here, the newest deterministic and probabilistic NBM run. And then this is looking at the probability of exceedance of 119 degrees, which is the all-time record for China Lake. You can see that there's a 25% chance on Saturday, 38% chance on Sunday, and a 25% chance on Monday for exceeding that all-time warmest temperature. So there is some chance for a high, all-time high temperature records being set. Looking at the probability of exceeding 114 degrees, and that's the daily record for, I think this is, yeah, the 12th. I chose the 114, the daily record for the 12th, because the daily records for Saturday are 113. So this is just looking at, the highest one of those daily records between the 10th and the 12th. And you can see that between Friday and Tuesday, there's a decent chance that daily records will be set at China Lake. So definitely some high heat. Looking at so I thought this was interesting. We did mention the bias correction earlier, or Andy mentioned this. I thought this was interesting, the difference between the bias correction today and yesterday. This is yesterday. As you can see, it's definitely, you can see the raw output, model output, clearly a bimodal distribution. And you can see that all the temperatures are bias corrected to warmer temperatures. On the right, you can see some of the ensemble members, and you can see that most of them are showing temperatures above 113 degrees. And I did put a note here that the Navy forecast is showing lower temperature than most of the other members. A few weeks ago, they did have a problem with that. The Navy showing significantly higher temperatures than the rest of the models, but it appears that they've fixed that problem. And then this is for today. You can see it's very different. The distribution is significantly different. It still appears to have two modes, but it doesn't. It's not as clearly bimodal. And you can see that all of them once again are bias corrected to warmer temperatures. And you can see also the trending to warm temperatures. You can see that the most of the models have gone up. Most of the temperatures that they're forecasting have gone up on the right, as you can see on the right. So this is the second point forecast that we'd like to look at. So this is for Hanford, California. Once again, Sunday being the warmest temperature or the warmest forecast temperatures for the heat event occurring on that day. So you can see the probabilistic forecast, the 25th percentile is 109, the median 111, and the 75th 113. You can see the deterministic is in that 75th percentile. It is the 75th percentile at 113 degrees. So Hanford, the max temperature at that location, all-time warmest temperature, is 116 degrees, and no ensemble members are forecasting that max temperature. So it's above the 99th percentile. It doesn't look like there's going to be all-time record set. However, there does look like there is a chance for daily records to be set. You can see this below. You can see there's a 25% chance on Saturday, a 38% chance on Sunday, and a 25% chance on Monday for records being set, as the daily record is 112 at that location for those days. Looking once again at the distribution, the NBM distribution, the model distribution, you can see once again the raw model is bimodal, and that you can see that the bias correction is a little different. You can see that not all of the members are being bias corrected to warmer temperatures. You can see some of them are being bias corrected to lower temperatures in this case. The resulting distribution is tighter, definitely, but it does still appear to have two modes, maybe suggesting two different situations. You can see that there's a large spread in the model data. You can see from 120 to in the GFS to 105 in the Canadian. So there is quite a bit of spread. So once again, this is for yesterday. We can see the change for today if we go to the next slide. Still appears to be bimodal distribution. Once again, some members are being bias corrected to lower temperatures, some of them bias corrected to higher, but it still appears to have two modes. And you can see once again, just like in the other case, the other point forecast, you can see that many of the models are trending warmer. From 105 degrees now at the Canadian to 122 at the GFS. So only a few degree change, but you can definitely see that trending to warmer temperatures. So just to put it all together, what we've mentioned about this heat event, putting together what Andy has mentioned for the cluster analysis and the European EFI, and what we've looked at the NBM. So what would an AFD include? Well, so the cluster analysis shows that a strong subtropical ridge will remain anchored over California, Nevada, and Arizona for late this week through early next week. We can also see that the European EFI and the shift of tails are both maximized in Central California, peaking Sunday and Monday with EFI at 1, and the shift of tails approaching 2. And this applies an extreme event at this location. The NBM helps to quantify the extreme event, looking at like what exactly are these temperatures going to be? What are the exact probabilities? We can see that for China Lake, the all-time record-breaking or the probability for all-time record-breaking temps is highest on Sunday with 38%, and daily record max temperatures will likely be set with 85% on Sunday, 50% or greater from Friday to Thursday or Friday to Tuesday. For Hanford, all-time record temperatures are not forecast to be reached or exceeded. However, daily record max temperatures are possible, and that highest chance for that is on Sunday at 38%. And this is just looking at the actual AFD at Hanford. You can see that they have put, this appears to be the probability of exceedance for the NBM. And they've actually been using these probabilistic information to relay the severity of this heat event at this area. And this is taken from their AFD published at 2:51 a.m. this morning. So now we're going to be moving on to the second part of this presentation. And I think, Randy, if you'd like to take over, she's going to be talking about a QPF event in the East.
Hey, thanks, Jonathan and Andy. Why don't we pause here? Is there any questions, comments, or anything that anyone wants to share on their use of these tools? Feel free to raise your hand or type into the questions pane. Yeah, I really like the probabilistic stuff that you were looking at there, Jonathan. I think that's just such a great tool. And Andy, your comment about the transition seasons, it was very interesting. So it really depends, like on the transition season, what your recent weather has been, whether the bias correction is going to be helping you out or hurting you. Right, if you're moving into a regime that you haven't experienced, then your bias correction may be taking you in the wrong direction. Okay, not seeing any hands raised or anything like that, so we'll go on to the QPF section. So we're going to take a look just briefly at some tools, and like Andy kind of mentioned, it's not so much about where the weather is occurring, it's more about the tools that we're using, and we kind of just want to kind of reinforce and have some sharing and some discussion of these different tools. As you all know, QPF in the medium range presents many challenges. You know, there's uncertainty, certainly with the evolution of an event. You have challenges with different ensemble members having different timing and location, which can smooth out your mean values and smear it out and make it look not as impressive. You have tight gradients when you have ensemble members are in good agreement and you end up with relatively tight gradients. Then you have challenges on the edges, especially of those gradient regions of how to handle and how to message. But one thing that, you know, if you think about it, there's been a lot of new tools available in recent years. The M-climate stuff's been around for about 10 years now from the GEFs, but some of these other ones are more recent. The weather and context, the EFI, and the NBM probability of exceedance, all can be really valuable tools to assess the potential for heavy rain. So let's go ahead and move forward, Andy. So what we're going to look at is each one of these. We'll go ahead and go to the next slide. I'm not sure what's going on with the bullets there. So we're going to look at M-climate and talk about this event coming up in New England. And basically, it's kind of the remnant moisture from Elsa is interacting with a front on Friday going through that region. And so we're going to look at M-climate. And so M-climate from the GEFs. And these are reforecasts that are run when we do new model upgrades. And this results in a model climatology. So you can see how the model is forecasting an event relative to its own climatology. So the new GEF was implemented in the fall of 2020. The resolution increased from 33 to 25 kilometers, and the members increased from 21 to 31. So the current climatology is based on the 2000 to 2019 reforecast. And the mean values are based on a 21-day running mean centered on the date of interest. So go ahead and go forward, Andy. Thank you. So the thing that M-Climate can really do for you is it can help highlight potential rarity or significance of an event relative to the model's own climatology. This is really unusual compared to what the GEFS has forecast historically. And so high M-Climate values generally equal strong agreement between the members. And then you kind of have to ask yourself, if I have strong agreement between the members, is it because the ensemble is under-dispersive, or is it because it's a predictable event? And ensembles traditionally have a reputation certainly for being under-dispersive, including the GEFS, although this version of the GEFS is not as under-dispersive as previous versions of the GEFS, but it's still going to be a little under-dispersive. So you have to consider that a possibility. Or is it a more predictable scenario? In my experience, most of the time when you get really high values out of the NAIFS ensemble for anomalies or the GEFS for M-Climate, it's usually a more predictable event. So what we see here is that in the cyan colors up there in Maine, that the GEFS has QPF amounts that are outside its own 20-year climatology. In other words, it's never forecast that much rain in this running 3-week window in that location. And you can see the probability or values in the greater than 99th percentile extend all the way down into Connecticut and Rhode Island. And you'll see on the table there, I highlighted the time frame we're looking at. It's the 24-hour forecast ending at 0Z Saturday. And as the max in the table there in the cyan is saying that this is greater than anything is forecast. And then you click on that, of course, and then you get the image that you see on the right. So let's go ahead and go forward, Andy. So now we're going to look at the EFI and the shift of tails that Andy described so well, looking at the heat event in California. And so I think this is more robust than the GEFS M-Climate. It's also relative to a model climatology, but it's got 51 members. It's 18-kilometer resolution, where the GEFS is not quite that high of resolution. And it's a little different because, as Andy mentioned earlier, its mean value is centered on a running 5-week period. So in this example on the right, you'll see, or the table there, it's got a 0.8. So it's near the upper end, but it's not quite as extreme compared to its own climatology as the GEFS was. And if you look at the image on the right, you can see that in the values there with the lighter green color is 70 to 80 as far as the percentile goes. And there's a few spots where the shift of tails and the black contours are around 1. So if you step forward, Andy, that was yesterday's forecast. And now this is yesterday's 0Z forecast that came out last night. And now you can see that it's up to 0.88. And you see a much broader swath of 0.8 to 0.9, indicating a bit of potential. And now you see some shift of tails up there. It's actually in southern Quebec that are up to 2. So there are some extreme values being forecast. But these are both really good tools to look at to try to get a handle on significant QPF events several days out. So let's move forward, Andy, and we're going to talk about weather and context a little bit. So weather and context is a relatively new tool, and I hope you folks have been looking at it. We've talked about it a couple of times or a few times on these weather briefings. It's a great way to see if the MDM is potentially or is forecasting record or near record values, whether it be temperatures or QPF. So on the top there, I have the table for the weather and context tool that shows 11 sites the MDM's forecasting record precipitation for, and 20 are greater than 50% of the daily record. Now, one difference between what we just looked at with the EFI and the M-Climate from the GEFS is those were both 0Z to 0Z forecasts. This is a day forecast. So this is Friday, as opposed to 0Z to 0Z. It's the day of Friday. So they're not quite exactly the same thing. But this is a great tool to get a quick look at MDM forecasts of potentially high-end events. And what you'll see in the map on the lower right there, as the cyan sites are greater 150% or record precipitation, so they're quite a bit above what the daily record is. The darker blue is 125% of daily record precipitation, et cetera. So you can see there's a swath from Maine all the way down into New Jersey that there's some record precipitation potentially being set or approached. So now we're going to look at a violin plot. So violin plots are really useful to visualize the distribution of the members. Now, it's not the full NBM distribution. This is the weather context tool has its own basic ensemble group, and it's mostly made up of raw and bias-corrected Canadian ensemble members and raw and bias-corrected guest members. And then in addition to that, you have WPC and NBM, I believe. And so on this violin plot, what you see is that WPC and NBM are highlighted there, forecasting about 1.75 inches for this location. This is for Providence, Rhode Island. And the yellow or the blue star shows that the record precipitation for the day is 1.31 inches. It's highlighted there. But here you can really see what the distribution is. You can see there's the whiter the violin plot, that means more ensemble members are forecasting that. So the most of the ensemble members are forecasting, between half an inch and an inch or so, somewhere around there. The 50th percentile looks like it's about 0.8 of an inch or so, something like that. So that was yesterday's. So one thing I want you to pay attention to here is we move forward is the scale on the left. So if you go back one, Andy, real quick. Yeah, so you can see the scale goes from 0 to 2.5, and now if you go forward again, the scale changes, right? So if you look at these sequentially, you might look like, it almost looks like it gets lower because the bottom, it's so bottom heavy on today's violin plot. But look where it's centered, that 50th percentile is now up at an inch. And now we have, so it's actually got greater values. And now at the high end, you have some members that are forecasting as high as like 4.5 inches, where we didn't have anything like that in yesterday's run. So there's some signal here, both in the EFI that we saw and in the weather and context from tool here with the violin plots, that there's some potential for a greater event that looks like it might be even heavier than it did yesterday. Okay, so let's move forward. And we're gonna take a look at just a few NBM probabilities. And so I really like this probability of exceedance information. It's great. I think it's a great messaging tool. You can really identify probabilities of specific values that matter to partners. So if you have a value that's important to a partner, if it's an inch or something like that they care about, in 12 hours, you can look at what the probability of an inch in 12 hours is using the NBM data. And you can it really allows you to have information to discuss the potential for different outcomes. Instead of saying just things like this is the most likely outcome and here's another alternative outcome, you actually get probabilistic information in numbers that you can essentially share. So one thing that really came out in a lot of social science work in recent years, and Joe Rittberger's review that he did for NOAA, was really the need to assign numbers to our confidence levels. So if we say medium confidence, I'd say, that's when I say medium confidence, I mean 40 to 50%. And at some point, in the agency, we're going to need to come to a standard on these sort of things. But it's really important that we do that in our messaging. So here's the image is a 24 probability of exceeding half an inch, ending at 0Z on Saturday. And we're kind of focusing here on Connecticut and Rhode Island. And you can see there's like a 60 to 70% probability of exceeding half an inch. You go forward, Andy, we're going to look at the 1 inch probability of exceedance. So now you're in the say roughly 35 to 45% range of exceeding 1 inch. And if we go forward one more time, we'll look at the probability of 2 inches. And so although it's not likely, there is around a 10% probability of exceeding 2 inches there in Connecticut and Rhode Island. So looking at this morning's, and I didn't add all these images, this all went up today. So instead of 60 to 70% of half an inch, it's 70 to 80, and the 1 inch went from 40 to 50 to 50 to 60. So they all went up. So again, the increasing signal as we're getting closer to the event, that the probability of a heavy rain event is increasing. So I think that's all I have on the NBM. I think we're at the, go ahead and go forward, Andy, the kind of the AFD part. And so just some thoughts, in how you might describe some of these things. So the ECM, WF, and GEFs are both forecasting mean QPF values that are significant relative to their own model climatology. The GEFs is especially impressive with 24-hour QPF values across northern Maine that are outside the ensemble's 20-year free-force climatology, and values in excess of the 99th percentile of the model climatology extend south of Connecticut and Rhode Island. Another easy way to say this is the guess is forecasting values that are rare for this time of year and location compared to its old monoclimatology. Very short and sweet. As far as the NBM, you might say NBM output indicates the potential for numerous sites to break daily record precipitation of values across Massachusetts, Connecticut, and Rhode Island on Friday. This is an example of how we would use those numbers and our words together. So NBM probability of exceedance indicates high confidence, 65 to 75%, that amounts greater than a half an inch will occur on Friday across Connecticut. The NBM provides medium confidence, approximately 40%, in amounts exceeding 1 inch. And if you had a partner who maybe was more interested in high values, even if they have low probability of occurrence, you could say, well, as low confidence outcome, approximately 10%, the NBM does indicate some potential for a more significant event with amounts exceeding 2 inches. So those are just some ideas on how you might share this kind of information in an AFD and provide that kind of context to the forecast that you're providing and be able to utilize this information to discuss the potential range of outcomes using actual probabilistic information and a sample output. So I think that's all we have